Hi, my name is Jennifer Miller, and this is my Lab 1 Charges on Tape presentation. The purpose of this lab is to experiment with everyday household objects and to see how these objects interact with themselves and other things. For example, one of the first interactions we did was to determine if the tape was charged by seeing if it was attracted to our hands. Some of the most important physics concepts in this lab are electric fields and force, conservation of charge, and conductors and insulators. What we've learned in class so far has showed us that invisible tape acts as an insulator and does not allow the charges on the separated tapes to move around readily. In addition, after rubbing a plastic pen through my hair, I have learned that the U-tape is positively charged. There are a few assumptions that had to be made in order to make the correct calculations for this experiment. The first is that we must assume there is no air resistance. The second is that the tapes act as point charges, and the third is that both tapes need to have the same net charge. In order to conduct this experiment itself, there are two tapes of the same positive charge. Tape B is then hovered in the air by tape A because like charges repel each other. This force from tape A acts against the force of gravity on tape B. Additionally, it is important to note that the tape must be handled properly in order for this experiment to work, because the charges on the tape can be easily transferred to a neutrally charged object, such as your hand. In fact, I had to do this experiment several times in order to get the correct reaction from the tapes. Here we see the quantitative data from this experiment. We can use the formulas shown in the following slide in order to see the specific calculations. A few things that we needed to determine were the length and mass of the tape, the distance tape B floated above tape A, the magnitude of the gravitational force of tape B, and the charges and the electric forces. As you can see, the mass of the tape is calculated from the length and density. The gravitational force on tape B is calculated by multiplying the mass by the gravitational constant. The charge Q is determined by taking the square root of the gravitational force multiplied by the distance tape B floated above tape A squared, then divided by the constant K, which is equal to 1 over 4 pi epsilon naught. From there, I use the E-field function that we wrote in Lab 0 to determine the value of the electric field of tape A. Then we use the equation force equals charge times electric field to determine the force that tape A projects onto tape B. As you can see, there are several different scale factors used throughout the code in order to make sure that each piece of the output is properly sized. After running the code, we see the following image is returned. Tape B is represented as a point charge in red, as it was in the initial diagram. We can also see that the tape B has two different forces acting upon it in the y direction. One is the electric force of tape A onto tape B, and the other is the gravitational force acting upon tape B in the negative y direction.